functions like I have this get keys.
All right.
Map.
So I vote that you all run the class today, and let me sit back.
Alright. Are you just tired?
Yeah, you know, between this class and compilers, like this morning, I'm trying to find the solution to the third project to demonstrate it, and it's all outdated. I'm just going, ah, crap, I gotta write another project. I got so much project work right now. You think you all have coding you have to do. Oh, man. All right, so a little bit of this will be a bit of a song and a dance. I'll kind of say, here's the project. Now come back on Thursday, and maybe I'll have more for you. I literally, while I was sitting here, I realized that I hadn't made Project 3 visible to you yet, so you can see that. There it is. There's a PDF, a couple PDFs. Let me start with Linux Toolbox PDF. This is a PDF I grabbed off the web. It was provided by some book publisher to kind of entice you to buy the entire book, and it just so happens that this specific chapter is very helpful for this class in general and this project in particular. As it says here in the title, it's debugging interprocess communication with shell commands, and some of these we have already seen. Some of these tools you may not have seen. This is one of those things where I'm not grading on it. I'm not going to check that you read it, but if you at least spend 15 minutes going through every heading, seeing what the tool is, type it just to confirm you understand what it does. It just puts enough of a bug in your head that when you run into a particular problem, you're going to remember that and come back to this document and go, okay, what was that tool? And it'll help you. So take me at my word that if you spend 15 minutes just doing an inventory of these utilities, it'll help you down the road. In addition to several utilities, it also goes into both message queues and signal handling, which is going to be the big thing in this project. Now, let me see here. See, there's my favorite, octal. There is, you may notice, where does it do the jump? Here's page 426. Here's page 431. I actually stripped several pages from this PDF. The missing pages, they cover a historic version of IPC tools that are considered outdated, but they present them considered prevalent in older code. It ends up just being confusing if it's in there and you're accidentally looking in the wrong section. So I stripped that out, and what we have is the newer, more current version of interprocess communication here. Message queues are just a way to allow you to pass, as it suggests, messages from one process to another on a machine. So that's what we'll be using that for. I'll demonstrate it here in just a moment. We're certainly familiar with semaphores already. And we'll be doing a lot with signals. And signals is what we'll be using to tell the other processes, hey, I've moved, update your screen. So let me show off this project here. I did mention that this is I knew it was going to do that. See, old code. All right. Let's see, how can I make this small enough? Let's go. This is going to be the world's most boring dungeon. There we go. Or not a dungeon, wrong genre. This is a map, isn't it? A miner's map, like they had in miner times. All right, we'll make this hallway double wide. Oops. I'm learning. And There, we'll leave that as a little onesie opening there. All right, let's see if that's small enough. So yeah, in this real old version, I had to actually provide a player number, which you shouldn't have to do. Okay, that's player 1. That's player 2. Note that when this player started up, the 2 appeared on this first player's screen. All right? All right. So when I move player 4 around, move player 3. Player 3 is going to grab this gold. Player 3 is my bottom left pane. So, of course, only player 3 is informed as to the nature of the gold. But player 3, looks like in this version you can't overlap the players, which is making player 3 mad because player 3 wants to get in that hallway down there. So player 3 is going to send a message to player 1. Player 3 types an M. And now any keystrokes are ignored until I type a 1, 2, or 4. Player 3 wants to send a message to player 1, so I type a 1. Now I type in the message, get out of my way, minor. And then player 1 gets the message saying from player 3. Now let me come up to player 1's screen. In the upper left hand corner I hit space to dismiss it. Player 1 gets out of the way. Also, in addition to M for sending a message, there's B to broadcast to every other player. B to broadcast. Hey everyone. Player 3 is a jerk. And that message is broadcast to all the others. So this is what the message keys are doing, allowing you to send messages to other processes on the machine. And then, let's see, where am I? Player 4, that's the bottom right. No one has the gold yet. Let me go to player 2. Player 2 will have player 2 find the gold. Player 2 found the gold. So player 2 can now escape. A message comes that player 2 is 1, except for the slow poke down here. Looks like I've got a glyph problem with my old version. Player 2 exits, and then these other players are still playing. And of course they have no recourse except to eventually type Q to quit. Let me go down to pane 2. So note that if you look over at player 4 that everything updates just fine, even if there's a message on the screen. And what's happening is this is all being done with signals, which means that when player 3 here is moving, player 3's process has a record of all other process IDs playing the game. And so player 3 is sending a signal to those other process numbers, and when those other processes, in this case, this process here, receives the signal, it interrupts wherever its flow is to run a signal handler, and that signal handler updates the map. And of course that all happens in milliseconds, and after the signal is processed, then flow returns to where it had left off. So in this case, there's some sort of keystroke that's being waited for here, and that's all that's happening is it receives a signal, and for a few milliseconds it leaves that routine waiting for a keystroke to run the signal handler, and then it returns to continue to wait for that keystroke. Okay, so that's how that works. There's some quirkiness with I/O that we'll have to deal with as far as when things are interrupted by a signal, but that's fine. We'll get to that. I keep doing that when we get there. We'll come over here, make that go away. So I guess these are the two players left, and so as these things start up, the process IDs are being stored so that everyone can access them and know who's playing the game, and that's how you determine where all the signals are being sent. So that player will quit, and that player will quit. All right, so that's the goal. Again, this is, I can't emphasize enough, this is an old version, and you should not be required to provide a player number. Just as we've done previously, it should figure that out automatically. Coming back to our project entry here in Blackboard, there's a project description. So let's see, I think that I've covered all this stuff. Maps update automatically, maps update, M to send message. There's if you recall the map class, so we're going back to our original map class, obviously. So the whole auto test thing was kind of a little side trip, and so what you're doing is you're taking your Project 1 code that is working just fine, your enhanced debug Project 1 code from Project 2, and then you're bringing back the original map class and the screen classes, or the screen class, I should say, the screen files, and just picking up from there. So your debugged Project 1 is your starting place for Project 3. In the map class, had a couple functions that we hadn't used in Project 1, and those get used in this project here. And M to send a message, B to broadcast, message when a player wins, cleanup, and also a little bit of signal handling to do cleanup if you get any sort of signals, like when you do a Control-C to break out of a program, what that's doing is that's sending a signal to the process, and if you read about SIGTERM, for instance, it says the default behavior of the process is to abort the process. But you can write a handler. So what you do is if someone types Control-C, rather than breaking out of the program horribly, what you do is your handler will go ahead and gracefully close things down, and if it's the last player, remove the shared memory and the semaphores and that kind of thing. Actually, I think it's sig interrupt. I think is Control-C. Just as a matter of trivia, does anyone know what HUP means? Hang up, absolutely. You would get that when the modem line would drop. SIGTERM, when you say kill and you provide a process, SIGTERM is what's sent. Which of course means terminator or terminate.
Can't you not write a handler for that one?
You can for SIGTERM. You can't for whatever. That's funny. I wonder why I wasn't getting. Oh, let's see. I want like an overview. See also, I want I'm not seeing it here. Let's see where it says. Probably sig kill or sig ill. There's one signal that to terminate that you can trap, and there's one that you can't. It's the signal number's 9. I just can't remember the mnemonic for it. 15, I believe, is sig terminate, and I think you can trap 15, but you can't trap 9. So I remember the numbers. I can't remember any of the signal names, and I'm totally spacing on. Which sig kill is 9, right? And then sig term is 15. What are you looking at?
Sig term.
Yeah. All right. So I'll go into the architectural stuff in more detail in a different class, but let's see what information can be provided. So getPlayer again is in the map class. So remember, when I hit M for message, it gave me a list of the 3 digits representing the other players. That's what getPlayer does. What you do is you send it a mask of the bits of the players currently on the board. It will present a menu based on those bits, and what it will return is which one was selected. And so that then you go ahead and send the message to that particular person. So that's that function. Get message is the other one that's in the map class. That's the one that puts up that blank box so that you can type something in. So you just call this function, and it'll give you back a string of what the user typed in, and it's the contents of that string that then gets sent to the person who it's supposed to go to, or if you're broadcasting to every other player. All right, so what's going to happen is, in order to facilitate being able to send signals to the different processes, we need to have an array of 5 elements, of 5 integers, essentially, representing the process IDs of the 5 players playing. And so what will happen is, when you join the game, just as it's up to you, before it was up to you to flip the bits for this player's byte, now it's up to you to add your process ID to this array. Okay, so that's how that works. Now here's a word of advice: is people are reluctant to re-architect code. Meaning, I'm telling you now, you're going to have an array of 5 integers, actually an array of these, which end up just being integers, process ID type. An array of 5 of these to store the process IDs, and there's a tendency to want to leave this here. Again, this is the 1 byte where you're throwing bits for when a player joins, and you're looking at this 1 byte and using masks to determine who's playing and who isn't playing. If you leave this here, you will invariably end up with half your code relying on that array of 5 and half your code relying on this byte, and it is just going to become a nightmare to debug. So one of the first steps for you to do when you're doing this project is you have to remove this from the structure completely, add the array of 5 process ID integers, and rework the code to get it working with those 5. That array of 5. Okay, you need to totally expunge this. Otherwise, if you have both of them, it's just going to end up being a buggy mess. This explains what should be done mechanically. All right. I'll again in a future talk more about message queues. The way it will work is that when you join the game, you create a message queue for yourself, but you're creating it for yourself read-only. Whenever you join a game, you find the other players. When you open their message queues, you will open them write-only. And that makes sense, right? You're always writing to others' message queues, and you're only ever reading from your own message queue. So that's the way that'll work. How do you know if you're going to get a message? We use, again, I haven't talked about it, we'll talk about it later. You use signal handling. A signal is generated to indicate that you have a message on your queue, and that prompts you to run the routine to go ahead and read in the message. I provide more code here on how to structure things, and that's about it. So our main technical challenge then will be to kind of bone up on how message queues work and how signal handling works. Once you kind of have those things understood, then it becomes a relatively straightforward exercise to get things operational for this project. It certainly is easier than the previous project. Okay. So what I'd like to ask you to do now is, over the next 48 hours, if you would be so kind and spend, I don't know, half an hour researching message queues and signal handling, and there's some useful information in that other PDF. You could also browse the web as well. Just get a little bit of familiarity about it, the function calls, what the general process is. You don't have to memorize anything. And then in class we'll continue to work with them and solidify our knowledge. Sound like a plan? Any questions about anything? All right, and let's bring it back here on Thursday.